All right, and we are live. So welcome everyone to the 13th ROS to Hardware Acceleration Working Group. As usual, the minutes are available in this. I'm sharing again for those of you that are making it into the meeting. Feel free to make any comments, suggestions, and as always, we'll try to review everything. All right, someone has asked to be removed from the recording, and I just got a message, so that should be fine, I guess. All right, yeah, so welcome to the meeting. As usual, there's quite a bit of people joining, so please, as in typical remote meetings, keep yourself muted if you're not speaking, and be mindful of whoever is taking the mic. We're going to have a 60-minute meeting. The first 30 minutes are going to be a discussion for the working group topics, which have been prepared in advance. The second part of the meeting is going to be a guest speech from Adam, and also Piotr from his team will be supporting. So yeah, let's kick it off. The first topic of the agenda is updates regarding the Robotic Processing Unit, and you can see that directly in the minutes. I'll be sharing my screen right now, just so that you guys can walk alongside me. So there we go. Can someone confirm you can see my screen?
Yes.
I can.
Thank you.
Sure.
All right. So yeah, first topic of the agenda, all business and progress review, updates regarding the RPU, in particular the mechanical design. So you can see the project link over there. There's been some feedback from some of you. Thank you regarding some user experience. So it appears that more and more people is building their own RPU, which is great. That's why we released it. One of the criticisms we've been receiving is that there are some sections in the RPU which are hard to access, some connectors specifically. That can be, I don't know if you can see it very well, but in here you can see some of the connectors themselves are very, very close to the borders of the outer box of the exoskeleton itself. So we have sent this feedback to the mechanical designer that's working with us, and we asked him particularly to please review this. And so in this iteration, which right now doesn't show, but hopefully we can go to the file in here. You should be able to see how there's been a array iteration in here, which has somehow made the spaces a bit bigger, and also with kind of like a squeezed surface so that you can access things more easily and put your fingers inside. So again, thanks for that feedback. And for those of you trying things out, feel free to retry it and do some feedback again if necessary. So that's one bit down. The second bit is regarding the Robotics MCU project, that some of you who have been following the project and the group know. This particularly aims to build a ROS2 native robotics microcontroller unit. And this is being tracked right now in this meta ticket right now in the community repository. And in the last meeting, we discussed some of the milestones that are expected to be accomplished. As a short kind of like target, we are hoping to have first working version of the Robotics MCU by the next official ROS release, which is happening in May next year. So Irwini, we'll do our best to meet it. Right now, the work has started. We are working on essentially the hardware side of things, porting the existing core BMCU into the KR260, the Xilinx or AMD KR260, which is the board we're using for reference development. And our partners from Plan B are taking care of that. Right over here, you can see a small report that I just submitted today based on the feedback that I got from Mustafa and Massimiliano and some others. But today we have in here Mustafa with us. So Mustafa, please feel free to maybe tell us a bit more of what's the status and how we are moving forward with this.
Currently, we are trying to implement the Core MCU on KR260, and we are a bit stuck on some PLL issues, but I think it will be solved quickly. And I personally am trying to add an Ethernet MAC to the Corby MCU. We have evaluated a couple of IPs, and we decided to use something from Alex Forenkik. I don't know how do you spell the name, how do you pronounce the name. And yeah, actually, that's the update we can give right now.
Thank you. Yeah, that's great. So I would say please keep up with the good work, and I'll continue interacting with you guys. As I suggested, Massimiliano, if you guys find yourselves kind of like cornered with the port and enablement in the PL within the KR260 board, do feel free to raise an open ticket. Possibly the best place would be the AMD forum, as I suggested over email. Mainly because if you guys do file an open ticket and provide instructions to people like us and possibly many others in here in this working group will go ahead, will reproduce it and report back, and that's going to put positive pressure. Plus, it's going to validate the fact that indeed that particular issue exists. But hopefully, as you just said, Mustafa, that's going to be banished and we can move forward. So yeah, thanks a lot again. Super happy, and maybe for the rest of you. As a quick kind of like refresher, and I'm sharing my screen again. Yeah, I think it's taking a bit. There it goes. So as I was saying, as a refresher, this first milestone should first tackle the port of the USB core to actually the PL of the KR260, and then we'll move forward into enabling FreeRTOS, and then on top of that, we're going to use an open source networking stack, and then possibly we'll be leveraging embedded RTPS. So there as the communications middleware, as the DDS implementation, essentially. Well, it's technically RTPS, but it has some DDS capabilities as well. But nevertheless, that's not fixed in stone. And we're considering other choices, which we are prototyping right now in acceleration robotics. So stay tuned by the time we land into that phase, and we'll let you know. Okay, so that's regarding the Robotics MCU project. Now, really exciting, RobotPerf. It was announced, so this is nothing new. For those of you who have been following the working group, we've been speaking about it at least for a couple of months already. But we certainly are disclosing more and more. Just today, we released the website of the project. That's available in here. This is all plain HTML, which lands in GitHub. So feel free to check it out and somehow contribute. It is particularly living in here. Here it is. So this is the site. And yeah, as I pointed out, it's just a matter of contributing in here directly. The project itself formalizes a bit more what we've been saying and discussing. As we said last time, anyone that's interested in participating should be doing it. And the effort over this last month has been pushing specifically to try to enable all of you organizations and individuals to somehow have a way to start contributing. So we find some preliminary categories that we believe make sense for partitioning the different benchmarks. Of course, we are emphasizing very much the why and why we're focusing on ROS2 as the common baseline in robotics these days. This will be discussed in this working group, if not every single meeting, very, very often. And again, opening up the door for many others to participate. Sure, Miriam. Sorry. So there you go. So yeah, as I was saying, super open to receive interest. We are still discussing the membership. We're going to try to set only some soft requirements and make about contributing with at least one benchmark and maintaining it. The actual work, the actual interesting juice is in benchmark repository of the RobotPerf organization, which does define the objectives once again, but also provide some preliminary intuition of what you can expect out of these benchmarks. I've summarized this, all these resources a bit more in here. I think what's more interesting is to show you kind of like how you can get started contributing and what you can expect in the coming weeks, months. So first of all, we prepared a specification that defines what each benchmark should be complying to. Again, this is likely to evolve in the following weeks and months, but right now we believe it's in a decent stage to bring it to your attention. So there is an explanation in here, again, motivating why, describing some general aspects that we believe are relevant for each benchmark to define, metrics, and also we put quite a bit of focus internally while discussing between Harvard and ourselves as the main drivers for now on how we wanted to have this benchmark so that they could be machine readable, but also somehow usable over time. So what we landed on is on proposing that each benchmark should be described in a YAML format. So be some basic IDs which should make each benchmark essentially unique in a way. And then there's a definition around the metrics, a description. There should be a reproduction section within the YAML, which essentially, not immediately, but over time, I presume we will use this to validate benchmarks in a continuous manner by using CI/CD infrastructure, which we will set up. This is not planned right now, but might be something we'll pick up down the road. And then, of course, the results with their corresponding timestamp and values, as well as hardware that was used to produce that. And then, essentially, a simple job, a simple CI/CD job is going to check each one of these files and produce the corresponding markdown files out of those. This will be auto-generated for readability purposes, but also this automatic review is the one who is going to end up pushing these tables that will summarize all of the results altogether. So that is how we envision this to happen, so that it's also somehow thought for integrating it with automated testing, which is definitely something we are doing internally. And yeah, this is pretty much still early stages, so very, very, very open for criticism and input and feedback. There's the skeleton of what you can expect. Again, the categories that right now we have proposed are these ones, which mean to grasp the most popular ROS2 packages and ROS2 stacks based on the surveys that we have been conducting for the last year. But that doesn't mean that we cannot kind of like go thinner into ROS2 abstractions, though, again, we're trying to stay a bit away from specifics because RobotPerf aims to grasp the complete robotics pipeline. We are using ROS2 as the common baseline indeed. But on a first stage, I would rather focus on the actual stacks than on abstractions such as interprocess, intraprocess, internetwork, intranetwork. I think those ones will come down the road later. So yeah, this is pretty much the state of RobotPerf right now. Very much looking forward for interest. If you want to contribute, you can start doing so. You can pick up one of these categories. You can grab one of the corresponding stacks, possibly the ROS2 implementations of those, and decide to instrument the corresponding section that you wish to benchmark and provide and propose the corresponding benchmark through a pull request. So that's a possibility right now. And of course, this is very aligned with the ongoing standardization effort alongside REP 2014. So reading that is actually going to be a prerequisite, and that's something that's specified in the specification. All right. So with that, I wanted to spend at least 15 minutes, which is what we have, I believe, for discussing some of the ongoing standardization efforts that are somehow empowering all of us to get together while building hardware acceleration kernels. We'll first touch briefly on REP 2008, and very excited to see what is the reaction of the group based on latest developments. And then I'll touch briefly on REP 2014 because there's been quite a bit of feedback from a number of companies. And I think at this point, it's worth collecting your input. So, so yeah, let's do that. So there's more than 50 persons today. I haven't checked if all of you guys have been following all the meetings. So even at the cost of being a bit boring, allow me to super quickly just go through Rep 2008 before I actually ask for a vote on whether people's happy with the current state. The rep itself is titled ROS2 Hardware Acceleration Architecture and Conventions, and describes essentially the architectural pillars and conventions required to introduce hardware acceleration in ROS2 in a vendor-neutral, technology-agnostic, and scalable manner. Putting aside a bit of the motivation, which you guys can go through it, what I will highlight is what is the value for stakeholders, specifically for you as ROS users, but also for package maintainers, if any of you is maintaining a package, and finally for silicon vendors and solution manufacturers. For maintainers, essentially, they can use these guidelines to introduce hardware acceleration in their packages in an accelerator agnostic manner. They can use some CMake macros that are defined that allow you to essentially abstract yourself away from the specific accelerator, whether it's a GPU, an FPGA, and so on and so forth. That is for package maintainers. That has significant benefits overall, but also package maintainers can further specify if they want to fit themselves to a particular accelerator. There are also CMake macros that allow them to fit with only one specific solution. So there's these two choices. Without what this rep provides right now, it's a complete nightmare of system integration, and each particular accelerator needs to be somehow attached to ROS2 in whatever manner you do want, which possibly is going to lead to, again, a nightmare integration. So that is one thing that we believe has lots of value for consumers like you, developers like me. This rep provides us a series of guidelines that allow us to essentially leverage hardware acceleration in a simplified manner, and also to set some expectations on how easy, how hard it is to leverage some of these technologies in combination with existing ROS2 stacks. Finally, for silicon vendors and solution manufacturers, does provide a series of guidelines on how they can fit into the ROS2 ecosystem, as opposed to reinventing the wheel every single time and forking ROS2 packages, forking ROS2 layers, creating further fragmentation and further complicating our lives as ROS2 developers. So those are the main objectives. One important thing to highlight, which was repeatedly discussed in the community and also in the steering committee, is that it wasn't clear apparently in previous versions that what was the final aim of this document. So this anti-goal section tries to depict that a bit better. The aim is not to define how you should be creating your acceleration kernels or which language specifically you should be using. You're free to use whatever you want, whether it's CUDA, it's OpenCL, it's HLS, anything you do want, and anything that your particular interests are, you're free to do so. At the same time, it's not the intention of this document to enforce any sort of hardware acceleration on maintainers or on users. You're totally up to, and the abstractions that are provided in here allow you to jump from one to the next one without having to actually modify your ROS2 source code. There's various kernel levels for hardware acceleration defined. You can read more in here if you haven't. What I'll do is just super quickly refresh your mind in terms of the two major, because there are more, but the two major pillars and contributions of this rep with their corresponding implementations, which are lower down in the document, are the extensions to the ROS2 build system, which allow us, again, to define a series of CMake macros to facilitate the integration of hardware acceleration technologies directly into ROS2 packages via these CMake macros, which can be directly used into your CMake list.txt files. And finally, the extensions and the creation of a new firmware layer, which allows you within your ROS2 overlay workspace to pack in there everything that's necessary firmware-wise for creating acceleration kernels for a particular technology that is supported, whether it's a GPU or an FPGA or any other accelerator, such as a TPU or others. Essentially, this lands into your ROS2 workspace, and then the build system extensions cross-compile and compile against these firmware targets so that it produces the corresponding cross-compile artifacts and accelerators as appropriate. So these are the two major extensions. The document has been simplified significantly, even if it sounds very long, trust me. We cut more than half of it, and I do believe it's in a very decent stage. There's also a methodology on how you can, if you want, create your acceleration kernels, and this has proven to be very useful for onboarding new people into hardware acceleration. This is something we're using very actively in our group, and also while mentoring some of our customers and clients. And finally, there's a reference implementation, which has been open sourced, is part of the ROS2 hardware acceleration working group, and part of the packages we maintain actively. So based on this, and again, as a refresher, this kind of like formal ROS enhancement proposal, kind of like standards in the ROS community, was drafted back in August 2021. So it's been around for quite a while now. I counted more than 10 reviewers and contributors from various organizations, and many of which, by the way, are active participants of the working group. So thanks to those of you in here. Various iterations of community feedback, of course, and this was presented against the TSC upon their request, which essentially confirmed that what we were doing sounded like something interesting beyond this working group. And finally, we're pretty much in the latest stages. The TSC has pretty much reviewed the document and shared that they are happy to move forward as a draft, provided that there's a majority of you that confirm that indeed that's the case. So I will call for a vote. That's my intention. Just a few remarks in here. So we're going to be registering the vote itself so that we can essentially then report and summarize the more people joining. Summarize the results anonymously, of course. If you vote no, please reach out and provide feedback. Despite how many of you do so, it's super important this happens, because of course we'll continue trying. And if it's not this month, it might be next month in January or in February, whenever we present it again to the working group. But please do send feedback, because the reality is that right now, after many iterations, as you can guess, there's pretty much no unmanaged feedback right now in the Git pull request, at least. So we do need not just, I mean, we don't need a no, we need a no and an answer about that. So feel free to share that directly with me or directly in the document if that's something you're willing to do. And hopefully I did prepare this properly, so I'm going to enable it right now. And all right, so I hope that some of you are getting, or all of you are getting right now, notification at the bottom right, and you can vote for this. Can someone confirm? You can see it?
Yes, it is visible.
Okay.
Yes.
Okay.
Yes.
So for those of you that may have missed it, because I was trying this before and it disappeared very rapidly for me, you can still find it. If you press on the bottom right of the screen, there is an activities kind of like section, which is represented by 3 figures. There is a triangle, a square, and a circle. If you press in there, and then there's a polling, in my screen is the first one. So if you're pressing there, you should see how essentially there is over there the polling thingy. So yeah, we'll let that run for some time so that you guys can vote on it. And yeah, the information is out there. What I'll do is I'll be moving forward, if that's okay for you. And once everyone has voted, we will stop it and disclose everything. So RED 2014, super exciting topic. Benchmarking performance in ROS2. This is a super relevant item, and it was very well received by a number of users. It was very well received, as I was saying, by a number of users. There's been very positive reviews so far, and this document, by the way, is not that old, I would say, so it's still very open for contributors and even authors if you can contribute enough to make space for that. So far, there's been some interesting and major feedback. I would say the major input has been processed already, but there's some additional feedback that requires additional work, which I hope I will get done over Christmas, but no promises there. Very interesting ones, I must admit. I do have, however, some concerns about some of the feedback, so I wanted to bring it up in here and kind of like capture your brains about what do you think, and what are the views of some of you in here who are willing to share it. So the one of the aspects that I am currently a bit kind of like hesitant about is that there is no implementation, reference implementation for this REP 2014, and hopefully by intersecting with RobotPerf, we can address part of that, because I think there are some aspects which you only see when you do implement it. So I'm hoping that part of the feedback that has been provided will be processed while implementing it, so that effectively I can answer more or better some of these queries, because right now I really don't have an intuition on how to approach some of this input that we are receiving. So I'm gonna throw here, let me see if this gets thrown appropriately. So I just threw two more polls to you guys. The first one touches on how should input data be provided to benchmarks. And the reason why I'm bringing this up is because there's been an interesting suggestion in the community around whether we should be focusing on receiving input in the benchmarks from one or another mechanism. So far, we've been pursuing an avenue wherein we're using simulation, Gazebo, essentially. But I think there's merit in some of the other suggestions that came around, such as using for systematically reproducing always the same result. There's also some voices pointing out about real hardware. So yeah, just curious about what's going to come out there. And we'll see that. I'll leave that running for a while as well. The second piece, actually, let me just explain the second one, and then I'll open up the mic, because I'm really interested in hearing some answers that I'm seeing in here, such as other. So the second question itself is about how should we require people to execute these benchmarks. There was a previous discussion last meeting around whether we should allow or enforce source code to be visible, or we can accept binaries, or we're just fine with the results and we accept that someone just run it in their machines and results are just fair enough. There's been some very direct feedback about this from silicon vendors, particularly from NVIDIA, regarding the fact that they don't accept or they wouldn't accept kind of like open source code like requirements, that they would require just the results to be pushed. And I think, frankly speaking, I think there is merit in what they are asking, because often the case the implementation might be proprietary. At the same time, I know how the ROS community works, and I know there's a clear bias towards disclosing the source code. So again, just interested to capture people's opinion in here. So yeah, anyone that wants to share her or his views around these two questions regarding REP 2014. I'm particularly very interested about those two persons that answered other in the first question around how should data be provided to benchmarks. So if someone can comment on this, go for it, Adam.
All right, so I answered ordered because I believe it's like a single answer choice, but I would like multiple. So basically, I believe if we are looking at benchmarking on a task level, because that's sometimes a useful thing to do, to benchmark a task. The task would use a simulation because it's interactive, so it's it moves in the environment somehow and accomplishes something. So you know, it needs this simulation. And at other times we're just benchmarking time to compute certain outputs, I believe. So then it's better to have rollbacks. So these are my thoughts, but I admit I might not be deep in you know, what REP 2014 is about. So apologies if that's the case.
No worries. And I think your answer definitely has merit. So one thing to keep in mind is that we want to compare performance computing, and from that perspective, we want to be as fair as possible, and it should be reproducible. It should be as reproducible as possible. And one of the criticisms that I've heard is that even though Gazebo is fantastic and possibly some say, I may say, the best simulator out there, the reality is that when it comes to reproducibility, unless you have a super simple scenario that's kind of like looping around, if you have like interactions in the environment, they may not always reproduce in the exact same manner. And so I think there is merit in saying that maybe a ROS pack would, for example, give us that kind of like determinism that might be required for comparing things fairly.
I agree. So my point was that if the thing that we are benchmarking for performance needs interaction and it's kind of changing environment, then that's where we have to use a kind of simulation, maybe a bit more deterministically set.
Yeah.
But otherwise, I think recorded data is best.
Yeah, no, and I see your point as well. And there was some input from I think the navigation maintainer, Steve, who essentially was complaining about the fact that he didn't see how a ROS pack would capture like some navigation interactions, and there's been some public discussion around that on how that could be stimulated. I think this is very new. It hasn't really been done as far as I know, and there's a chance right now for all of us together to drive this forward. So yeah, thank you everyone who answered. I think we can kill now all of the polls, and I will disclose everything. So let me finalize all of them. There we go. And just kind of like a remark regarding RobotPerf and Rep 2014. We have the chance to kind of like influence this this opportunity of how benchmarking happens and how things can be compared fairly. I think this is a very exciting project. For context, we're not creating this anew, but we are actually building on top of past efforts. And for those of you that did not attend to the last presentation, we're working with the group in Harvard, which actually created MLPerf, an ML Commons, or is behind it, which means that that has become the industry standard for machine learning, to be frank, when it comes to comparing benchmarking computations in AI and machine learning. So hopefully we'll learn from all of those lessons and get things right in robotics. Having it in a ROS2-centric manner is fantastic. So again, encouraging everyone to reach out, to contribute, to be proactive on this, and we'll be looking forward to hear from you in this regard. Regarding the polling and the results so far, I'll be, again, digesting and sharing the percentages. I'm super happy to see that the first poll regarding the acceptance of Rep 2008 has turned out into all positive votes. So very happy about that. And just a reminder, the fact that this may lead to getting the draft accepted doesn't mean it's kind of like set in stone. As any rep out there, you can send pull requests. You can actually contribute it further and you can improve it. And actually you should try to improve it. So hopefully that sends a message and everyone gets to contribute there. But yeah, we're past the first half an hour, and I'd love to hand it out to Adam. Sorry, coughing. To Adam in here. So Adam Dabrowski, he is the principal software architect in Robotec.ai. He is beyond that a super nice guy, a good friend, someone I know very well, and super excited to see what he and his team are up to using this essentially RobotecGPULidar they came up with. Peter and Adam, I would love to see out of you guys maybe a contribution for a benchmark that could land in RobotPerf. I think there's definitely ground for this work. And with that, looking forward to hear you.
All right. Thanks a lot for this super nice introduction, Victor. And I'll just start to present. I guess you can see my slides right now. Just someone please confirm. All right. Yeah. So let's get it going then. All right. So our company, deals with modern ROS and simulation with robotics. That's a brief introduction. And the why this GPU LiDAR emerged is because we often deal with performance-demanding use cases. So that's a kind of organic. We value open source. We contributed and continue contributing to ROS. I will be talking a little bit about that in regards to Gazebo. And here we are talking about GPU acceleration, and namely CUDA-based for LiDAR simulation. And while I contributed to this project, its leading author is with us. It's Piotr Rybicki. And I understand that this group has a broad interest in acceleration. This part is about accelerating simulation, so it's a bit specific, but I understand still within the interest of this group, as simulation, I think, is quite crucial to robotics. So just a brief introduction. Of course, there are many application fields for simulation, and we have at least 3 different categories of goals. So it's very different for many users, how they see a simulation and what they need from simulation. So, of course, they like to develop the robots, prototype, test algorithms, but also to have these validation cycles, scenario runners that actually enable them to say, my robot behaves so-and-so, and this is a good behavior in a certain scenario that I can simulate. And then, of course, many models for machine learning benefit from synthetic data, which is easy to produce in mass quantities, as long as you can kind of guarantee that it's still useful. It's not as far removed from the real data to not be useful. This can be of great value. And then we have many simulators. Of course, everybody knows Gazebo and Ignition. But we also have plenty of simulators which are based on game engines. We have Carla, which is based on Unreal. We have AutoWare, Awesome, so AutoWare simulator based on Unity 3D. These are just examples. So we have, of course, other proprietary solutions, which are many. And also we have open source engines. And a good example here is O3DE. So these are quite different simulators. There are many. Of course, we are talking about simulating sensors in each of them. It's always a little bit of a different problem, but also, as it turns out, for simulating sensors, there's much in common which can be abstracted into a common library. So why game engines are used so often? It's because of performance. Often that's the major issue with other types of simulators, and also with Gazebo, especially where we have large areas to simulate. We have all these optimizations in game engines for such things, because games were demanding, were always demanding, and will always be in terms of performance. So, of course, we are looking at some use cases which deal with many robots. For example, autonomous cars equipped with sensors that are quite performance demanding. And if it needs to happen in real time as well, many even strong desktops can be challenged by such performance needs. So these setups that actually pose this challenge and make discussion about what hardware is good for a simulation platform, these are quite common, actually. And large performance is not just kind of user experience, but it also makes simulation less useful. You can always use this real-time factor if it's available for your solution, but yeah, it's degrading how fast you can process things, how fast you can validate, and so on. So acceleration matters, and for LiDAR, we will talk about our solution, open source solution, which has been just released and presented already at ROSCON in Kyoto. Good example of this performance issue is comparing our library to another open source LiDAR simulation. It's a bit apples to oranges, so it's a very light comparison because of also different features and different approach. But we have 1,000 times more rays per second than the other solution. So RobotecGPULidar. A nice race trace logo by our colleague, and some features. What are we looking at? We are looking at a library which is C-based. It has C API, so it's quite easy to bind and plug into different simulators. It's Apache 2.0. It's for Linux and Windows. Why Windows? Because these game engine simulations, they are typically better, running better at Windows. And people make advantage of this, running this simulation on Windows and robotics stack on Linux, right? So this can, of course, network, send the data, and sometimes it's the case that this is needed. As I mentioned, it uses CUDA and optics, so it's not for every stack, but it's quite a popular setup. It will use RTX cores if available. It's based on modern technology. You have this diagram here that visualizes so-called pipelines. It's quite modular in a way. You can compose the computational pipeline and determine what kind of pre-processing, post-processing you want to have. So you can decide you don't want to visualize, or you want to save the data to your PCD file. For example, you are using it to prepare a map of environment, right? So you would like that. You can even determine that you want to publish this to a ROS to topic right away. So you don't want to return this data to the simulation, then again, publish it. You want to save some performance here and publish already using the library. So this is quite useful. The feature with ROS2 integration is already in current version for Ubuntu, for Linux. For Windows, we have a kind of fix that is actually a patch to RCL CPP. That's outstanding there. That will also enable this to work. And as I mentioned, there is high performance, which is the selling point, I guess. Except there's no selling, there's no sales. But if you want to use it and you you really need to simulate a lot of rays per second, I guess that's a very good thing. And the numbers here, 350 million rays per second, are on our modern laptop device, so it's not a expensive simulation platform. And there is still plenty of room for improvement. So I guess you could see animation here. Just let me know if it's visible.
It is visible.
Yeah. So I think that this illustrates quite well how the GPU LiDAR simulation works. And so it illustrates that it's real time. The bottom right one kind of shows how you can switch between different patterns of firing. So we have this feature where you are able to customize firing patterns. Even what we did was replaying actual firing pattern recorded from a device. So exactly the firing pattern, which was you can determine how large of a sample you want to use, and for example have a file of 80 something megabytes as we did, right? Which only saves the pattern. And then yeah, the bottom left one, I think it's quite beautiful. It shows the performance, and you can notice these are automotive use cases. There we have these beefy sensors, this Velodyne Alpha Prime, lots of points. So this is where it comes from. LiDAR simulation using CPU for these use cases is just not feasible.
But of course, the presentation itself takes away a bit of performance here because
yes,
GIFs are. So yes, this is like 60 FPS with multiple LiDARs, and exactly those GIFs can be seen in the link I posted on the chat.
Yeah. So there is always an issue when you are streaming something that's supposed to be running smooth, and you want to demonstrate that it's running smooth, right? Because the streaming itself make it appear not so. But under the link, you actually can see these GIFs operational, and you can use the repository itself and reproduce this. All right, so we have some examples. We already have plugin for OSIM. So we started with AutoWare. For these who do not know what AutoWare is, this is the largest open source ROS2 based stack for self-driving vehicles. So we are also a part of it, and this is where it comes from. But aside from these examples that you saw, we are also working in different fields of application of robotics. And here you can see a nice image from Apple Orchard use case, which we actually presented as a demo, and it's available as a demo also online. So here we are integrating RobotecGPULidar as a plugin into O3DE, Open 3D engine. And we have some nice screens also from real-time operation in OSIM, as well as application where it's actually it has been used to produce this nice point cloud map. And then what's the current plan? We would like to add intensity. We have interest in machine learning data, and we want to pursue how intensity channel can be used to improve detectors. There is much unresearched area. We would like to also have some headway in that. And instance segmentation is another application which is quite good to train AI. Other features like points cloud skew and realism. Just we have some noise models and so on, but we would like to also add options at this pre-processing, post-processing options that improve realism and add features that are needed. And here I mentioned plugins. We are preparing 2 plugins which will be available shortly. So O3D plugin, it's in works. It's expected already by the end of the year, so quite soon. There is a thing like O3D ROS to GEM, which it plugins into. Basically, it's an game engine which is open source, right? And it's available for robotic simulation. So we target it because we believe it will be impactful in the future. And then, of course, Gazebo plugin, which I think could be quite impactful for community as well. We had a lot of interest in integrating this for Gazebo, and we are aiming also for a very quick release. You can see some of our work in progress. It's already quite advanced. We want to integrate it with Gazebo sensors, so it's available out of the box. So Gazebo already has a GPULidar library, but it's quite different in operation. So it uses depth cameras. For those who are interested, I think that this is a bit of a technical, detailed discussion, but we can run comparison and why our plugin could be of benefit and interest to all of you. All right. So summarizing, you can find I will share this presentation, of course. And you can find useful links here to the GitHub repository. Or we also described this on our blog. You can expect plugins to come soon. We are also cooperating with a couple of people from Gazebo. And we would love to have your feedback and feature suggestions. And would love to have this become also a part of robotics community, and to have contributions, actually. Right, and that concludes my presentation. I hope that was useful to you, and I'll be happy, along with Piotr Rybicki here, to answer your questions. So
that was fantastic. Thank you so much, Adam and Peter. This is very exciting, and let me just make a quick comment by saying that this fits perfectly fine with this working group. When we created this working group way more than a year from now, we did define the mission as driving the creation, maintenance, and testing of hardware acceleration in ROS to Gazebo. And by that, we wanted to embrace robotic operating systems with ROS and simulation with Gazebo. So definitely very fitting, I would say. And hopefully some of us will have a chance to get a look at this and do fulfill that ask that you just made about contributions and comments. So super exciting. I do have one question, but I'll say it now. Any questions from any of you guys about this or the previous discussion? Go for it, Dylan.
Are there any plans in the future to target different devices as from like CUDA and the other device? I can't remember the name, sorry.
So basically, we are. This is based on CUDA and optics. So it's an implementation choice, which it will be quite a lot of work, I guess, to support other architectures. But Piotr, correct me if I'm wrong. This is a choice to kind of get the most of performance, but you kind of need to have this device. So I think it fits quite well with these assumptions in the rep, where if you have this kind of architecture available, then this could be a choice you could pick.
Yes, also, and NVIDIA, as far as I remember, was the first one to come up with hardware-accelerated ray tracing, and the optics API. It was there for a long time, so that's why it was chosen.
It's quite mature, yeah.
Yeah, so maybe I can just mention briefly. There's definitely lots of good reasons why you guys picked optics and CUDA, and given the fact that CUDA is likely the most popular language framework for hardware acceleration, I would say that was definitely a very good choice. And this, by the way, comes from the benchmarking we've been performing with this and the overall robotics community for the last year. But for those of you interested, particularly Dylan, you asked on porting this to other platforms. Leaving aside optics, which is a bit of a different thing, but on the CUDA side, actually, you may find that some other frameworks for hardware acceleration can ingest CUDA directly. For example, AMD's ROCm, which is the framework, has directly a way to ingest CUDA. So you can actually leverage the same piece of code that you may run on NVIDIA GPUs, also in AMD GPUs, while leveraging the same piece of CUDA code. Again, leaving aside the optics thing, which is yet a different discussion, but at least part of the work is pretty much addressed already. So yeah, a good starting point, I would say.
So I would just comment that if AMD guys decided to contribute, that would be a huge contribution, of course, and we could have multi-platform library in a sense of acceleration platforms.
That is the objective of this group. Yeah, hopefully that happens. I'll definitely keep that in mind and try to forward the AMD guys to speak with you guys. That's going to happen. Hopefully something sparks in here. Good. So maybe a quick question from my side, but to you guys, Peter and Adam, you shared some data regarding the capabilities you have obtained based on the introduction of hardware acceleration. Do you have any CPU baseline you have compared this against? Because and this matches very well with the discussion today, right? With RobotPerf and Rep 2014, because it's all about comparing performance and obtaining that baseline benchmarking data. So do you have any data in terms of what's the speed up?
So this is a complex question, as all of you quite well know. So it's no matter how things are compared. If you're trying to sell something, you can always pick axes of comparison that make your product look better. We kind of try to avoid that. I made just one comparison to another open source CPU LiDAR solution, but I said that these are different libraries, realize kind of different things. The comparison was like we can simulate 1,000 times more rays per second, which is a huge number. However, of course, this is not the same process, not the same output, and so on. And it would be unfair to kind of stop there. For comparisons, we did kind of compare early with the GPU LiDAR in Gazebo. the one that's there. So we are faster. But it's kind of, again, it would be great to have this with a methodology, with a proper several platforms, and so on right now to avoid any kind of bias. And it's always, again, not about performance, because these are different things. Gazebo plugin uses depth camera and not raycasting, which is a very different approach. So in terms of geometries, in terms of like 360 degree LiDAR simulation, so you have 4 depth cameras, there is kind of lack of smoothness in the solution. Where we have ray tracing, it's it looks better, and so on. So we can discuss this kind of soft features aside from hard numbers, and comparison is quite complex, I would say. But we have comparisons which are based on physics engine raycasting versus GPU raycasting. Again, this is like not as big as the Helios example, but also at least an order of magnitude, if not more. And exact science, exact results, we would need to really run benchmarks. But we are not selling it, just try it out and see that the performance is quite impressive.
Thank you. Thank you.
Thank you.
I think Jasvinder has a question.
Yeah. Hey, hi, Adam. So I'm not sure whether even my question is correct or not. So I just wanted to understand, like, have you measured the accuracy of, like, is it functionally correct, the simulation, or like because in the environment, like how close like the points are. So how is the actual data coming? So do you have that data also, or measured that data?
So this is, again, a very complex question, because if you're asking about realism of so one big framework question is realism of simulation of anything, right? And you can ask about how realistically would this simulation represent the actual sensor given these and these and these conditions of weather, whatever, and there are many factors, right? We have, for example, statistical noise models, which are not per device or specific noise models, which can be determined by studying outputs of device. We do not have influences of weather and so on, so we don't simulate the physics of diffraction and so on. But raycasting is, I would say, has much more potential than the depth camera, right? So if you're comparing which one it can be better used for simulating actual LiDAR behavior, and then raycasting has an upper edge here. But of course, there are different kinds of simulation in industry. If you want exact physical simulation of how things happen, typically you won't get real time anytime soon, like even with a very small kind of sensors. So from my experience, for simulation, you want it to provide value. So you want only to be realistic enough as to actually inform you about the behavior of your robotic stack. So what you are trying to validate here, right? You don't need to be any more realistic than that, than to provide plenty of value.
Yeah, makes sense. Yeah, got it. Thank you.
Thank you.
All right. Any more questions from anyone? Comments, suggestions? Go for it.
Maybe a quick question regarding the RTX. Which one you are using?
So
the RTX 6000, A6000?
Piotr, you might be the best person to answer, actually, which one you run on.
No, I just wanted to, I don't want to focus on the RTX, but and the NVIDIA environment itself. Are you maybe planning to try that with iGPU instead of discrete GPU? Because discrete GPU in general, you need like a beast, or from NVIDIA side, you have Clara HX or Holoscan, and then it is like quite not easy to have. And my question is, are you planning to use the iGPU at some point from the NVIDIA like platforms?
I think this should run out of the box on those GPUs. Or whatever support is wherever optics is supported, it should work well, just without RTX hardware acceleration. But we didn't try that yet, Adam.
Yes, we were kind of going with platforms that we had and our customers had. So these were RTX based. We didn't extend our tests beyond the platforms that we actually use.
Yep.
That could be useful. That could be useful to try.
Maybe I can try it at some point.
Yes,
because I have the majority of NVIDIA platform here.
That would be great. If you
I will let you know, guys.
If you could try and share this.
Yep.
If you run into any issues, go ahead and publish. I think I will try to help.
Yep. No worries. Thank you very much. Do you need a specific CUDA version with all dependency with the GPU? Because with RTX, NVIDIA released the OpenRM driver. This is open source, and then you don't have the same features as the proprietary code. Then maybe you need to be careful here. But I will try it, and then I will let you know. Definitely.
Excellent.
Thank you very much.
Thank you.
Appreciate it.
All right. So I believe everyone that we've reached the top of the hour. As always, any further comments or questions can be dropped into the minutes. Regarding the polls that happened, data will be anonymized, and we will share the results of those in the corresponding ticket of this meeting, in the Discord thread of this meeting, which I believe is this one that I just shared in the chat. And yeah, I think that's pretty much it. Any final comments from everyone? Otherwise, I wish everyone a very, very, very happy rest of the year, and we'll meet next year.
All right. Thank you, Victor. Thank you, everyone.
Thanks a lot, Adam. Thanks a lot, Peter. It was fantastic to have you, and we look forward to have you more in the future. Thanks for your contributions.
Thank you, guys. Have a great evening. Bye-bye.
Yeah, thank you, Peter.
Ciao, ciao, everyone. Thank you so much.